name is Alex, and I'm going to discuss about gene polymorphism, substation by chemical classifier for age-related macular degeneration. So today I want to discuss about what is age-related macular degeneration, what is gene polymorphism, how the test has been performed in order to obtain the results, and at the end I'm going to conclude everything. Gene polymorphism is a change of nucleotide or multiple nucleotides inside a gene sequence. This mutation is very rare, it is not present in many individuals. The age-related macular degeneration is a progressive degenerative disease of the central macular region of the retina. It is causing vision loss, as you can see in this picture here. So the disease starts with a black patch, small black patch, and is going to develop and to get bigger until you are going to lose your vision. As I already said, the macula is the yellow spot on the retina, which makes a sharper vision. The retina is at the back of the eyes. Its function is to change the image and the pictures and the light into signals and send them into the brain. Macular degeneration is caused by damage of the blood vessels that supply the macula. You can see in this picture, on the bottom left picture, you can see the dry macular degeneration, yeah, and the right side you can see the wet macular degeneration. In this study, I'm going to focus on wet macular degeneration, which represents the abnormal growth of the blood vessel under the macula. The main question is which of the gene is causing the disease. Well, the part of the study is to find out which gene is the cause of the disease, as I already said, or which of the genes has an important contribution to develop the disease. In this study, the study has been performed using 10 sets of genes, such as 2 factor 5, factor 5 G1691A, and factor 5 H1299R, proton B, G20-210A, factor 30, beta-fibrinogen 455, plasminogen activator inhibitor 1, human platelet antigen 1, 5,10-methylene tetrahydrofolate reductase, 2 types of methylene tetrahydrofolate reductase, 6,770 and 1,288C. And at the end, the last subset of the gene is angiotensin converting enzyme. The test was performed by using a test set of genes. Those 10 genes was transferred and used concomitantly with the KLA classifier inside the MATLAB, and at the end, I obtained those results. This is the table that represents the best functional models for age-related macular degeneration disease. I will perform more than 46 tests, but I found those 10 the most relevant genes, most relevant results that leading or decreasing the risk of age-related macular degeneration. So, in the first subset represents the test of all set of the gene polymorphism, and we obtain, I will obtain 76% accuracy. And the highest score that has been obtained has been created by inactivating the factor 5 1299R from the subset of the gene, and we have obtained, we have here a total accuracy of 81%. This is the highest. The highest round number is going to increase the disease, increase the factors to develop the disease. We see in the in the previous slide, I've shown you those two columns. You can see the sensitivity results, and the specificity results. Yeah, the sensitivity and the specificity plays an important role into determining the disease state. Yeah? The sensitivity and the specificity are the statistical measures of the performance of a binary classification test. Yeah? In this graphic, you can see that true positive, true negative, false positive, and false negative. So true positive represents the sick people correctly identified as being sick. Yeah? The true negative represents the healthy people correctly identified as being healthy. The false positive represents the healthy people incorrectly identified as being sick. And the false negative represents the sick people that are incorrectly identified as being healthy. The sensitivity and the specificity are mainly based on the first two columns, and the true positive and the true negative. True positive represents the sensitivity, and the true negative rate represents the specificity. So true positive represents, as I already mentioned above, in the previous. The true positive represents the sick people that are correctly identified as being sick. So we can see in my graph that the true positive is higher than the true negative, which means that the data set that has been used represents a higher class of sick people. Yeah, 102 sick people. This slide represents the result that has been obtained, the accuracy of 76%, by activating and using at the same time all of the 10 genes polymorphism. Yeah? A particular focus has been made for factor 13 gene polymorphism. Yeah? Whose effect is well known in age-related macular degeneration. Factor 13 and angiotensin are the polymorphism genes that, following my research, are playing an important role in inducing age-related macular degeneration. So if you have a look at the first table on the top, the blue and the gray one, you can see that using factor 13 and angiotensin converting enzyme, we obtain higher accuracy. We have higher accuracy in there, yeah? We have 76 for all of the genes, 7143, 7143 as well, 7619, 8095. Yes? You can see the inactivation. If you can look at the subset number 4, you see the inactivation of PAI1 doesn't modify any genes, doesn't increase or doesn't decrease the disease state. It's going to be the same, like using all of the 10 genes. Yeah? So the table one relates those 5 relevant tests that are considered to be relevant. Yeah? Also the concomitant use of those above mentioned polymorphism genes, in addition with factor 5 exclusion. By excluding factor 5 is to the highest accuracy. So you can see in the subset 5 here. So excluding factor 5, you are going to obtain the highest accuracy, the highest, you're going to increase the risk of developing age-related macular degeneration. But the concomitant use of all of the genes, factor 5, angiotensin converting enzyme, and all of the other genes, excluding NTHFR 677T, yeah, the methylene tetrahydrofolate reductase, you are going to decrease the number, the accuracies, which means in my opinion, by excluding methylene tetrahydrofolate reductase, inhibit the action of those well-known genes. Factor 13 and ACI, you can find lots of papers, lots of research papers that relates the fact that those genes play an important role in age-related macular degeneration. So by excluding anti-AGFR 6 over 17, you are going to inhibit, you are going to decrease the risk of developing age-related macular degeneration. This results represents none of the genes as we test, excluding factor 5, that I already said, yeah? Which is used for 80% accuracy. So, by excluding this gene, the factor 5 gene, is not going, that's the protein, the factor 5 protein, the factor 5 protein, is not going to produce all this protein, which means, which I consider the thrombophilia increase the risk of age-related macular degeneration, because factor 5 is not going to produce the protein, so this protein is not going to have any effect on age-related macular degeneration. This table represents the particular focus that has been made in angiotensin converting enzyme. In my opinion, angiotensin converting enzyme, I performed this test in order to see which of those two genes, angiotensin converting enzyme or factor 13, is more dominant into developing the age-related macular degeneration. So in the top table, in the blue table in gray, we can see that we obtain a broad range of accuracy values. You can see from 47 to 81%. In this test, as we perform different, as we exclude different types of genes. But all I want to mention is that by excluding the first three, subset 2, subset 3, and subset 4, you can see on the bottom line the green table. By excluding this, by excluding factor 13 from the subset, by performing the test without using factor 13, we obtain the lowest accuracy, the lowest risk, which means the factor 13 is much more dominant than angiotensin converting enzyme. Also, by excluding anti-AGFR, I already said it is going to be lowest, to be as low as possible, the accuracy. In this slide, you can see the result that has been obtained by excluding dose factor 5, dose to factor 5, prothrombin, and factor 13, and it will lead to the lowest accuracy values of 47%. In my opinion, by excluding factor 13, which is the most important, most dominant gene inside into age-related macular degeneration, by excluding this gene, you are not going to produce the protein, which leads to 52% accuracy. So, in the conclusion, I would say that the age-related macular degeneration is a degenerative disease that is going to lose. You are going to lose the vision. Yes. So the current study has been made in order to find out which of the genes polymorphism has an important contribution to develop the disease, or if we which of the gene causes the disease. Yes. In one hand, factor 13 and angiotensin converting enzyme important role into developing age-related macular degeneration. It cannot be stopped. Likewise, the inactivation of factor 5, gene polymorphism, contributes to the risk factor. The highest results obtained has an accuracy of 81, almost 81%, which means the individual with factor 13 gene activated, inactivated, is much more prone to develop the disease. So if the individuals have the factor 5 inactivated inside their bodies, the protein is not going to be produced, and the risk to develop age-related macular degeneration is higher. On the other hand, the inactivity of factor 5, 1691A, and factor 5, 1298R, prothrombin and factor 13, gene polymorphism, may decrease the risk of age-related macular degeneration. Well, that's all what I want to say about age-related macular degeneration and gene polymorphism. That's the main cause. Thank you.